So it's a very powerful, come to half a second just to summarize that point. It's a very powerful dictionary in some sense. You now have two ways of describing a given physical system. You can describe it sort of in the conventional way that we've always thought about it, as a three-dimensional world that has comings and goings, or you have an alternative language if you want to make use of it, which is the physics that takes place on this thin bounding surface. And sometimes that latter description gives you insights that are very difficult to obtain from the traditional description. And we're going to come to a version of that in just a moment. But yeah.
Yeah, I think that you can make the picture a little bit more clear perhaps by realizing that whenever you throw something into the black hole, when you look at it from the outside, you will never see it actually pass through the horizon. It hangs around at the horizon. So it shouldn't be too surprising that that information also hangs around at the horizon.
Yeah, so can I just flesh it out for half a second? So what Gerard is saying is, if you look at how a black hole affects the passage of time, you find that as a clock gets closer and closer to the edge of a black hole, the clock ticks off time ever more slowly. So if you're watching this from very far away, the object is starting to go in slow motion as it goes toward the edge of the black hole. It doesn't just immediately go over the edge. In fact, it goes so slow that it would take an infinite amount of time from your perspective for it to actually fall over the edge. So it hangs out there.
The outside observer would think the clock is standing still.
Standing still.
But actually the clock is simply showing the time that the observer who goes with the clock sees that, oh, that's the time I'm going through the horizon.